Okay, now we're going to talk about um, H10I, derivatives of e to the x and natural log of x. So we did a Desmos exercise earlier, and this green graph here is y equals 2 to the power of x, and this one here is the derivative of 2 to the power um, of x. And actually, we don't know that that's the derivative, but this is the derivative of that. And if I've got y equals 3 to the power of x, this is the derivative of that. And notice how the derivative on 2 to the power x is the slope is less than the actual function, and here the slope is a little bit bigger than that of the function. So the thing that we come away, the comments, similarities and differences. So the similarities is they are both exponential. Okay, um, and the slope in red also seems to be exponential. Um, the differences is they're not exactly the same. Okay, so um, so what so when I have 2 to the x, the derivative function is slightly lower. If I have 3 to the x, the derivative is slightly higher. What value do you think would have the derivative being exactly the same where the green and the red lines overlap? And when we do experiments on our calculator, as you see later on in this assignment, you're going to find that if I take the derivative of e to the x, then we're going to get values that are the same here. So using the derivative function on your calculator, let's see, I have notes on that on the next page. I do. So you can copy down those notes in a second. But if I type in y equals, and I have e to the x. Okay, and I can graph that. And that's my graph. And if I want to find the value, so let's just find out. So if I plug in e to the x, if I plug in 1, let's get a table here, second graph. And at -1, I've got 0.3678. At 1, at 0, I've got 1. When x is 1, I've got 2.718. When x is 2, I've got the 7.38. When x is 3, I've got 20.08. Okay. Now, if I want to use the derivative function on my calculator, I can do second trace, and I go down to the sixth one where it says dy dx. I hit enter. And now if I want to find, let's just pick 2. So if I want when x is 2, so all I did was hit 2, enter, and now it tells me the derivative is 7.389. It's the same answer. Let's do second trace. Go down to 6 derivative. Let's find the derivative when x equals 3. All I have to do is type in 3 and enter, and the derivative when x is 3 is 20.018. Basically, this little experiment with this table, they wanted you to figure out that when I have the derivative of e to the x, it's going to be the same. Sorry, if I have a function e to the x and I take the derivative is going to give me e to the x also. That is the most important thing of this entire handout. Okay. So here are the notes for using the derivative function on your calculator. You might want to hit pause and copy this down. You push the y equals button, you type in your function, you press second and trace to get the derivative, and then you type in the number that you want, and then you hit enter, and then it tells you the derivative at that number. So, so they wanted you to sketch the derivative of this green line is y equals natural log of x. Okay. And like I said, hit pause if you want to, so you can copy this down. Now I'm going to cover it with my calculator so I can do this. Okay, so I've got my function natural log of x. So clear natural log x, enter. So okay. So second trace, if I want to find the derivative, so there's my derivative function, enter. There's my graph for natural log. When x is 1, I hit enter, and the derivative is 1. Second trace, down here, enter. When x is 2, we're going to get 0.5. Second trace, derivative, enter. When x is 3, I hit 3, enter. I get 1/3. Second trace, go down to derivative, enter. I'm going to type in 4. When x is 4, I'm going to hit enter, and I get 0.25. And then we start noticing these are the answers. So the slope of this gives me 0.5, 0.33, 0.25, 0.2. And then if you notice, this is the same thing as 1/2, 1/3, 1/4, 1/5. So the important thing, the conjecture, is if I have y equals natural log of x, the derivative is going to be 1 over x. Now you won't need to memorize that because that is going to be in your formula packet. So if I can find my formula packet, right here, e to the x, derivative is e to the x. If my y equals natural log of x, the derivative is 1 over x. So you're going to be using that to do your derivatives. So if I did the derivative when x equals 10, we're going to get 1/10. Okay, so you might want to hit pause to copy this down. What base should we use when we're differentiating exponents and logs? We should use base e. It provides the simplest results. Why are the exponential functions with base e so special? So exponentials and logs can be differentiated of an exponential function with base e leads to itself, and this produces the simplest answer. So it's special because it provides the simplest answer. Okay? So, hence these formulas that we use on our formula packet. Okay, so I'm just going to walk you through these. So when I see this here, I know that I'm going to be using product rule. I've got natural log. Here, let me just do this here. So I'm going to, using the product rule, I have y prime equals u v prime plus v u prime. Okay, so I'm going to make u equal to x, and I'm going to make v equal to natural log of x. The derivative of natural log of x we now know is 1 over x. The derivative when u equals x is going to be 1. And now I can plug it into my product rule. So then I get equals x times 1 over x plus v is natural log of x, and u prime is 1. Okay, that simplifies to 1 plus natural log of x. Okay. Here I'm going to be using, this was product rule. Here I'm going to be using chain rule. Okay, I'm going to let y equal e to the power of u, and u equals 4x. So dy du is equal to e to the u, because e to the x, the derivative of that is e to the x. So knowing that, e to the u, the derivative of that is e to the u. And if u is equal to 4x, then I can say u prime is equal to 4. Or let's not call it u prime, let's du dx, right? And chain rule says dy dx equals dy du times du dx, right? So that's going to give me e to the power of u times 4. And then we can simplify this now, and we get 4, because I'm going to put that in the front, and then e to the power, I'm going to replace u with 4x. Okay. You might want to hit pause or rewind to listen to this again, but we're going to be using this relationship in the next example on the next page. So basically, if I've got y equals e to some number x, the derivative using this relationship is going to be equal to that number e to that number to the x. Okay, we're going to be using this relationship on the next page. Okay. Okay, so now we need to figure out this one. Okay, this one, the way it's written looks a little bit tricky, but I'm going to write this as y equals sine u, and u equals natural log of x. So when you write it this way, then it looks like it's going to be chain rule. Okay, so derivative of sine dy du is cosine u. Derivative of u, du dx. Derivative of natural log of x, we know, is 1 over x. So dy dx is equal to cosine u times 1 over x. And I'm going to replace u back with natural log of x. So our dy dx is equal to cosine, and what is u? Natural log of x, and then this answer times 1 over x. Okay, hit pause if you need to. And I'm just going to show the key and walk you through these here. Okay. I'm going to use the chain rule here. Natural log of this blue stuff, and that blue stuff is x squared plus 1. Derivative of natural log is of something is equal to 1 over that something. Derivative of 2x, x squared plus 1 is 2x. And now I'm replacing this and this with that and that. And then I substitute u with this stuff here. Okay, let's talk about this one. Product rule. I'm going to make x equal to u equal to x, e to the x. Okay. There's my product rule. Okay, chain rule. I'm going to make y equal to e to the u. I'm going to call this blue stuff u. And if if u is the blue stuff, try to say that 10 times fast. U is blue, U is blue. Ooh, okay. So derivative of 2x squared is going to give me 4x. Derivative of e to the u is e to the u. If I'm using chain rule, then I'm going to say e to the u times 4x, and then I'm going to replace u with 2x squared. Okay. Question D, we're going to use product rule. So u is going to be equal to t squared. V is going to be natural log of t. Derivative of t squared is 2t. Derivative natural log of t is 1 over t. And then we use product rule. Okay, next page. Product rule again. And this one here, let's talk this through. So u is equal to 2x plus 1. Derivative of 2x plus 1 is 2. V is equal to e to the 2x. So remember we did something like this on the previous page. Remember where I said where did it go? We just did this. Oh, it's on this other handout. Duh. Okay. Remember what we said? If I've got e to some number x and I take the derivative, we're going to have that number e to the x. So here I've got e to the 2x. So basically e to the number, and that number is 2. So I'm going to get the derivative e to the 2x is 2 e to the 2x. Okay. And now I can apply the product rule. Okay, here we're going to be applying the quotient rule. Okay, check your work on these two. The derivative of e to the 4x is going to be 4 e to the 4x, but we had this coefficient of 2, so this derivative gives me that. Okay, and the next page. Okay, next one down. Oh, let's talk this through. They wanted you to use log properties. So, okay, I'm going to hit pause. You can hit pause if you want to check this out. You can hit pause if you want to check this out. But I'm going to work out a couple of these and explain it. Okay, so using the log rules, I can use the power of log. I can bring this to the front, and I can write this as y equals 5 natural log of x. This is called the power rule for logs. And then we know the derivative of this is equal to 1 over x. Okay, so using the log laws makes this way more simple. So using the power rule for logs, this can go at the front, and I have 4 natural log of 2x plus 3. And I can say 4 times 2 and 1 over 2x plus 3. Okay. This one's a little tricky. We can write this y equals natural log of x plus natural log of x minus 3 squared, because the log properties are, I need to get a formula packet out. Okay, so if I've got log x, y, I can write this as log x plus log y. Here I've got log x, is that? And we could simply call this log y if we're using that formula. Okay, and then now I can use the power rule and bring that to Okay, so I just brought the 2 to the front using the log power rule. And now we can take our derivative. This is equal to 1 over x. Oh, I should have put a prime there. And this is equal to 2 times 1 over x minus 3. I hope this was helpful. Okay, now we've got the if I've got division, log x divided by log y, I can write this as log x minus log y. So I can rewrite this here as natural log of 2x plus 1 minus log of x, or natural log of x. Okay, it's this thing, log of that, minus log of what's in the denominator. Okay, and now I can take the derivative of that, and I get 1 over 2x plus 1 minus 1 over x. Okay, I hope that explanation made sense. Let me know if it doesn't. Here's E. Hit pause if you need to. Okay, 5 is a really good question. Okay, so I use the quotient rule with this, right? U equals e to the x, v equals x plus 3, du equals 2e to the 2x, v prime is equal to 1. We put it in the quotient rule for derivatives, and it simplifies to this. Okay. Now, we want to find the coordinates of a point of a tangent to the curve that is parallel to the x-axis. So if it's parallel to the x-axis is horizontal, so that means the derivative is going to be 0. If it's horizontal, that means the slope is 0. So we're going to we found the derivative, we're going to make the derivative equal to 0. Now, in order to make the derivative equal to 0, I need to make this equal to 0. Okay, and so if I make that equal to 0, then I know I could say 2x plus 5 equals 0. Subtract 5 on both sides, 2x equals negative 5. Divide by 2, x equals negative 5 over 2. Okay, so now to find the y value of the coordinate, I'm going to plug in negative 2.5 into my original function. So I've got my original function, and I'm plugging in negative 2.5, and then we get this value here. And this is the y value for the coordinate when x is negative 2.5 and y equals this. For this coordinate, the slope is parallel to the x-axis. Okay, now the normal of a line that is parallel to the x-axis, the normal is going to be straight up and down. If the normal is straight up and down, then that means the slope is going to be undefined, and basically it's a vertical line that goes through this y value. You might want to hit rewind and listen to that again. Okay. And then here's 4a. Here's 4b. And here is 4